Hi, my name is Gustavo and I am a student in the Digital Forensics class at NYU Poly. In this presentation, I will be introducing a new forensics tool aimed at facilitating the analysis of Outlook emails in a relatively short amount of time. I named this tool Inception because it quickly provides a starting point to forensic analysts from which to begin an in-depth study through visualization of the email history contained within the Outlook's data file. It is designed specifically for working with large volumes of data in the order of tens of thousands. By plotting the result output of this tool in a social network type of graphic, an analyst gets a bird's-eye view perspective of the social life stored in these files, gains insight of who the main characters are, looks at the evolution over time, and the tool may even suggest the existing hierarchy within the social system. We will first export the emails from Microsoft's proprietary Outlook data file into the more popular EML format because there is a wide array of additional forensic tools available using this format that we may want to take advantage of. Then, during the parsing process, we will be collecting strictly metadata, the date that mail was received, the senders, and each recipient email addresses. With this collection of metadata, we will then produce statistics and generate a network graphic file in which nodes represent an individual or his email address, and lines between the nodes represent communications between two individuals. We will record the frequency of each node based on the number of times it sent an email, and likewise, edges between the nodes will receive a weight based on the number of times an email exchange occur between the two individuals. The tool is a Microsoft Windows-based application written in C#. Its interface consists of two tabs. The first tab provides the interface for processing and configuration options, while the second tab displays useful statistics. The processing tab is subdivided in three areas, each representing a process step in the workflow: exporting, parsing, and graph generation. Let's begin by importing a data file using the browser button or by typing its file name and then clicking on the export button. During this process, each email will be saved in an output folder. In this particular sample, we can see that the user has organized the email files in folders. As a result, the extracted email files will be organized in their corresponding subfolder. This process can take a few moments, so I will go ahead and speed up the video. Once the process has finished, we can take a look at the Statistics tab. Here we can see that the number of emails exported were over 5,300 emails in less than a minute. The parsing step offers a couple of options. We can select from two different sets of recipient addresses and set a date range for the emails we want to parse. After the parsing has finished, we are ready to generate a graphic to help us better visualize its data. But first, let's take a look at what we got so far. Our parsing time took about 12 seconds, and our graph has around 2,100 nodes and 78,000 edges. The graphic data is in a GEXF format, which consists of an XML file with basically three different sections: a header specifying whether the graphic is static or dynamic, with some optional parameters such as the date ranges and any attributes we want to define for our nodes. We then have the nodes section with their attribute values, and in our case, each node represents an email address. The last section contains edge information indicating the email exchange between the two nodes. Optionally, we have added the weight to the edge and the source and target addresses, which help us tell the direction of the email exchange. We have a couple of graphic tools we can use to display our network graph. I chose the Gephi graphic tool, which is a Java-based open source tool. I like this particular tool because of the various formats that it's able to support. The initial graph in the Canvas section doesn't look very helpful, but we can use the attributes in our data to get a better visual of what is going on. Let's use a gradient color for the nodes based on their frequency, and also we can specify a range of sizes relative to their frequency. Let's try between 25 and 100. Now the main characters have become prominent. Next, we can apply a layout. Layouts allow our graphs to be laid out with force-based algorithms. They follow a simple principle. Linked nodes attract each other and non-linked nodes are pushed apart. We can position the nodes of interest in a way to better disclose the relationship they are having between each other and between the owner of the mailbox. Now let's enable the timeline and choose a window size of between 1 and 2 months. As we slide our time window, we can see when these main characters came into play. There is a node that appears around this time frame and is displaying a strong leadership role judging from the directional arrows that indicate the number of conversations initiated by the node. We can disclose the email addresses right on the canvas with this button here. With the information from this visualization, I was able to then go and focus on a small set of emails, and what I discovered is that these nodes here belong to team members that have been working together since the beginning of our timeline. The graph is owner-centric, and this node represents the owner of the mailbox. These key team members joined the group in the August-September timeframe. And this node represents the new program manager that the entire team began to work under in the early October timeframe. Recapping, we processed over 5,000 emails in less than 2 minutes, quickly identified the main characters and the point in time when they all came into play, and just as important, we were able to draw the organization of the social system. As with any tool, there is room for improvement. I like to see how a geomap based on the IP metadata would look like, or make an analysis on the response time to each of the addresses in the threads. Similarly, we could use additional attributes to flag nodes with whom the mailbox owner had side conversations on any given thread. You may think of others, and I welcome your feedback and any questions you may have. Thank you very much for watching.